Simplifying radicals or radical. So people tend to struggle with this when we're doing a lot of trig or different types of stuff. This is usually the mistake. All right, it's not really in the higher level mathematics. It's these simple kind of computations. So simplifying a radical. So what does that mean? Well, we're going to look at predominantly just square roots. So there's a little vocabulary that we have to understand is you have square roots, perfect squares, square something. So let me show you some perfect squares. So this is 1 through 16, if you look at it that way. So the perfect squares are on the right hand side. So 1, 4, 9, 16, 25, 36. They're perfect squares because the number, how you got them, was squaring the exact same whole number. So we're using the word perfect. So basically, let's take 3 squared equals 9. Okay, so 9 is a perfect square. Its root, okay, the number that made it is 3. All right. So 144 is a perfect square. Its square root, or the beginning, right, what made it, is a 12 squared. So we have to understand that vocabulary. Okay. So you basically need to memorize these. All right. So let me show you how we're going to do this. So if I asked you what's the square root of 25, I need to know that 5 times 5 is 25. The answer is just 5. Okay. Sometimes people ask, like, how do you know it's plus or minus? Don't worry about that right now. Basically, plus or minus comes when you're dealing with an equation. These are just expressions. Okay. The square root of 49 equals, well, I need to know that 7 times 7 is 49. So the square root is 7. That's what it's asking me. That symbol is my square root symbol. The square root of 256, 16 times 16 is 256. And so I would say 16. Okay. All right, so now let's look at when they get more complex, because this is where people start to make their mistakes. So we have this nice little rule, and it basically says, if you look at this, the n means they're all the same square roots. They're all squares or whatever they are. So I got the same radical. And if I have two numbers being multiplied underneath the same radical symbol, that's the same thing as me multiplying two individual radicals. It comes out the same. All right. So if I did the square root of 50, well, this is not a perfect square. So if I want to simplify it without using a decimal, I need to use this rule. So basically what I'm going to ask myself is, can I break up 50 in terms of multiplication or factors that use perfect squares? And if I do that, let me do a couple and it'll kind of make sense. So if I know 25 times 2 is the same as 50, and also I could also use 5 and 10, right? But 5 and 10 are not, neither one of those are a perfect square. That's why I use the 25. So now here's the radical rule. I can split this up and say, oh, okay, the square root of 25, so it's 5 times the square root of 2. I simplified the radical. Okay, if I punch those into a calculator, I would get the same decimal approximation, but I want the actual simplified exact answer. All right, so 20. So 20, that's going to be 2 times 10, 4 times 5, right? But I don't want to use 2 and 10 because neither one of those are a perfect square, but 4 and 5, right? 4 is a perfect square. Split that up, all right? And then take the square root of the one that is actually a perfect square. And there's my simplified radical, all right? Square root of 12. So I got 3 times 4, 2 times 6, 1 times 12, right? Pick the one that has a perfect square, and 4 is the only perfect square that is in there, all right? Use my radical rule to split those. Take the square root of 4. So my answer is 2 root 3. This is a simplified version of the same radical. The square root of 98. Okay. So this is where you might want to just mess around with your calculator and start plugging in some of the perfect squares and see what you can get. And this is the same as 49 times 2. Right? And I can split that up to the square root of 49 times the square root of 2. My answer is 7 root 2. Square root of 48. A lot of factors in this one, right? 2 times 24 and all the way down. So I'm looking for the biggest perfect square. And what it's going to get people here is people are going to try to use 4, right? But 16 is the biggest perfect square that divides in there, okay? So that's going to be the square root of 16 times the square root of 3, 4 root 3. Square root of 45. So think of the biggest perfect square that goes into 45. In this case, it's 9. 9 times 5. All right. Split those up into their individual radicals. And I get 3 root 5. Let's do one more here. The square root of 24. The square root of 24 is 4 times 6 is the biggest perfect square that I can get out of that one. All right. Split those into individual radicals. And I get 2 root 6.